Okay, fine. Begin the session. Good afternoon, one and all. Now, the session is concerned with the module 4, which is the time response of feedback control system. So far, with the control system, we had the discussion concerned with the basic concepts of control systems, where known what is control system, classification of control system, then mathematical modeling of control systems, mathematical modeling of the electrical system. Later, we concentrated with the two more important topics, that is the block diagram reduction technique followed by signal flow graph. Now, with that signal flow graph, we learned to find a function with the help of Marston's gain relation. Is that okay? Right? That is concerned with the module 3. Next, I need to concentrate with the module 4. As per your curriculum, don't get confused. Now, in the slide, it has been indicated as module 3. Like, strictly speaking, this is concerned with the earlier syllabus 18 EC 43. You need not to once. And your subject code is 21 EC 4, which is 21 EC 43. Like, what the parameter we have been discussing that is associated with the module 4. Is it okay? Next, we need to concentrate with the time response feedback control system. Majorly, it is concerned with the stable system. That you need to understand it clearly. Now, what is the learning objective of this session in the sense? Majorly, the learning objective of this session is to understand the concepts of standard test signals and unit step response of first order system. Probably the slides you may expect little bit late. Slide it has been indicating through this learning objective. What is the learning objective of this session? To understand the concepts of standard test signals and to understand unit step response of first order system. Next, how about the flow? We shall have it in the sense. The flow is as similar to this. First, we need to understand something associated with the feedback control system, that is the time response. Normally, the response of any control system or feedback control system is associated with the sum of two responses. One is the transient response and one more is steady state response. First, we will understand what is the difference between transient response and steady state response. Normally, if I try to have any control system and if I start analyzing or if I start evaluating the output of the control system, the output of the control system can be evaluated with the help of two distinct outputs. Those outputs are transient output and steady state output. Response normally it refers to the output of the system. That you need to understand it clearly. Now with the table of content, like what are all the things we need to concentrate in the sense? Initially, we need to understand those responses. What is transient response and steady state response? Later, we need to concentrate with the standard test signals. Now we have four types of standard test signals. Those are all step input, parabolic input, ramp input, and like impulse input. These things you need to understand it very clearly through mathematical relation, right? Physical existence and Laplace associated with that. Next, by understanding those parameters, later we need to concentrate in analyzing or in understanding unit step response of first order system. This first order system is very basic, and based on the first order system, we will be concentrating with the second order system, right? Unit step response of first order system, second order system, and we need to understand the time domain specifications of first order and second order systems, followed by problems, right? These are all the things what we need to understand it. Now coming to the next important criteria, that is the time response of feedback control system. Now, as I told you very clearly, the time response of feedback control system majorly is performed for, you can have a look, the time response of feedback control system, majorly it is performed for stable system. Is it okay? Right? I repeat, time response of feedback control system normally, now this time response of feedback control system has two parts. Now, as I told you very clearly, transient response One is very important thing, that is transient response, and one more is steady state response. Now, what is the major difference between transient response and steady state response in the sense? Normally, you just try to have an example. If I try to make any changes with any of the input, now what the changes we shall make it at the input, that it takes certain time to reflect at the output. Is it not this? Now, even if I try to say something, let me take the example of our online class itself. Because of the signaling problem, now I may deliver the things at some time, but you may able to receive the same signal after some time. Is it okay? There will be some delay, right? And the delay, what exactly we will have, that is normally it is referred to as transient response. Is it okay? That you can understand it very clearly. Whenever there is some change at the input of a system, the output of the system is incapable of responding to the change instantaneously. Why? Because if I try to have any of the practical systems, that is very clear. As such, if I try to make any changes with respect to the input, the changes it gets reflected at the output after some time. Is that okay? Why? Because it is not instantaneous, right? And what the time, finite time it takes to respond, that time is normally it is referred to as transient time. Is it okay? That is normally it is referred to as transient time. And in transient response analysis, the system is always checked for the speed of the response. Is it okay? Now, why we will check for the transient response? The transient response majorly it is checked for the speed, to know the speed of the indication, like how about the speed or how about the time it takes from responding from input side to the output side, and that always we measure it through this transient time via transient response. Is that fine? Now this is concerned with the transient response. Then coming to the other response, the other response is associated with the steady state things. Now this steady state response, you can have a look. In steady state response, the system is checked for steady state or accuracy. You please try to have. Now I'll give an example. Now this is the frequency or this is the response what we expect for first order first order system. Unit step response of the first order system. Now, with this, I have been indicating two things. This part is transient and this part is steady state. Now, let me understand the things very clearly, transient and response. Now, this portion is referred to as transient. This is transient, wherein this is referred to as steady state response. Steady state response, you can have a look. Now, from the definition, it has been clearly given that steady state response, the system is checked for the accuracy. Now, from this point to this point, the system is accurate. Why? Because you won't have any variations with respect to the output. Now, how with this time? Now, with this time, there is variation from input to output every. Is it okay? It takes certain finite time to reach from zero to this maximum value. But it is the maximum value. This maximum value is normally referred to as steady state. This is always referred to as transient response. Is it okay? One good example can have human life into two distinct what do I say in the sense, we can have our human life into two distinct portions, right? One portion until we live on this earth, and when as soon as we live from this earth, that is the steady state, and until we live on this earth, that is the transient response. Is that okay? Now, in the steady state response, the system is checked for steady state accuracy. That means in steady state, output of the system should be capable of following the input without any steady state error. That means the gain is maximum. And these are all the differences between two kinds of responses, that is transient response and steady state response. Now, performing the time response analysis. In order to carry out the time response analysis, we shall use four types of standard test input signals. What are all the four types of standard test input signals we come across? The first is impulse input. What we have? Impulse input, step input, ramp input, parabolic input. These are all the four standard input signals what we come across for analyzing any control system. What are those inputs? Impulse input, step input, ramp input, and parabolic input. Already we come across this kinds of inputs even with respect to signals and DSP. Probably parabolic input may be new to you. Other than this, like you guys have exposure about impulse input, step input, and ramp input. Now, if I try to take each of this, first let me begin the things concerned with the step input. Is it okay? Now, how about the step input? You can have a look. This is the representation of a step input, T versus R of T. Now, in signals and DSP, we understood unit step input. Unit step input in the sense the amplitude is equal to 1. But it is not unit step, it is just step input. In case of step input, equal to some finite value, that finite value we have been referring it to through this A, capital A. You can have a look. Now, what is step input? It is a function. A step function is a signal whose amplitude will change from one level to another level in zero time. Normally, changes occurs from zero level at t is equal to 0. Is it okay? And mathematically, how do I represent that step input T versus R of T? And this is the amplitude of the signal. Now, how about the amplitude of the signal? It has been indicated by A. For unit step input, that A it becomes 1. That difference you need to understand it clearly. Is it okay? Now, how do I represent this? In signals or DSP, I might have represented this as U of T. Now, instead of U of T, what we have? R of T. Is it okay? Now, if I try to have R of T, you can have a look. R of T is equal to 0 for T less than 0 and A for T greater than or equal to 0. Right? This step input, I may represent it in terms of unit step function as A into U of T. What is U of T? U of T is unit step function. Is that okay? Where U of T is called unit step function, which is defined as similar to this. U of T is equal to 0 for T less than 0 and 1 for T greater than or equal to 0. Right? Now, in our case, you need to remember two things: the mathematical expression, physical existence, and the Laplace concerned with these cases. Now, how about the Laplace for this? The Laplace for this is quite simple. Laplace transformation of R of T. That is nothing but the Laplace transformation of A into U of T. Is that okay? Transformation of U of T. It is 1 by S. Thereby, for a unit step input with amplitude is equal to 1, is equal to 1 by, right? This is concerned with the step input. Coming to the second kind of is a signal whose amplitude will vary linearly with respect to time. That you can observe very clearly. This is the linear variation. Is that clear? This is the linear variation. Right? Now, in signals or DSP, we have learned unit ramp function, where slope is equal to unity. But in our case, it is not unit ramp, it is ramp, where slope is not at all equal to unity. That you can observe very clearly. What is R of T? R of T is equal to A into T into U of T. Now, what does this A indicates? This A indicates the slope value. What does this A indicate? It indicates the slope value, and unit ramp function is indicated with this T into U of T. Right? Now, how about the math, like Laplace associated with this? R of x is equal to A divided by S square. A divided by S square is the Laplace associated with the ramp function, and A divided by is the Laplace associated with the step function. And we have two more input signals. What are those? Next input is parabolic input. Ramp input is the first order input, wherein parabolic input is the second order. That is the one difference. A parabolic input is a signal whose amplitude is proportional to the square of the time. But how about this ramp input? where the amplitude is proportional to the normal value, that is t. But how about in case of parabolic input, whose amplitude is proportional to the square of the time? Now, how about the mathematical expression for this parabolic input? R of t is equal to a into t square by 2 into u of t. This is second order. Parabolic input is second order, wherein ramp input is first order. Now, if I try to have Laplace associated with this, what do I get? R of s is equal to a divided by s. Is it okay? Now, how about for ramp input? It is a divided by s square, normal ramp. Ali unit ramp bantu andre, it becomes 1 by s square. Is it okay? How about the Laplace for parabolic input? A by s cube. For unit parabolic, I may take a is equal to 1, then it becomes 1 by s cube. Is it clear? Now, these are all the three standard test input signals. We have one more thing, that is impulse function, delta function. An impulse function has finite amplitude only at t is equal to 0. Now, we can observe this is at t is equal to 0. At t is equal to 0, if I try to have the amplitude as 1, this is unit impulse function. Now, if I try to have some other amplitude as such a, then it becomes impulse function. In controls, we won't have unit case. We'll have normal step input, ramp input, parabolic input, and impulse function, where amplitude is not at all equal to unity. That you need to understand it clearly, right? An impulse function of finite amplitude is practically not possible. Function delta of t is practically possible. Is that okay? Now, you need not to worry much about these things. Now I'll go for the Laplace associated with each of the four test input signals, what we have learned so far. Now unit impulse function, right? For unit impulse function, what is the Laplace associated with that? The Laplace associated with that is equal to 1. Is it okay? What is the Laplace? What is the Laplace associated with the unit ramp input? 1 by s square. What is the Laplace associated with the unit parabolic input? That is 1 by s cube. You need to remember the mathematical expression, physical existence, and Laplace associated with this four test input signals. What are those? Unit impulse function, unit step input, unit ramp input, and unit parabolic input. This is the first set. Now, with the second set, I need to understand time response analysis of first order system. Now, with the time response analysis of this first order system, what exactly we'll be carrying out in the sense, we'll take some first order system, for that we'll apply some input, and parallelly we make an attempt to get the output. Now, what kind of input I shall apply for this in the sense that the name is self-explanatory, time response analysis of first order system. Now, with this, the response what we analyzing is unit step, or the input what we used to apply is unit step input, or this is the unit step response of the first order system. Is it okay? Now, like this is the block diagram of first order system what I have been concentrating. Actually, this is G of S, open loop control system. What is the value of open loop control system G of S? 1 by Ts. 1 by Ts. Is it okay? Now this is first order system. ಏಕೆಂದ್ರೆ ಇಲ್ಲಿ ಎಸ್ ಇದೆ, ಎಸ್ ಬದಲು ನನಗೆ ಎಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಇತ್ತು ಅಂದ್ರೆ ಅದು ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಆಗ್ತದೆ, ಎಸ್ ಕ್ಯೂಬ್ ಆದ್ರೆ third order. Is it okay? Right? This is how exactly we'll be differentiating between the order of the system. First order system, normally it is associated with a single term s. For second order system, we have s square. For third order system, we have s cube. For fourth order system, it will be s to the power of 4. Is it okay? Based on the degree of the s, we will be deciding as such it is first order or second order or third order or fourth order system. Now, what I have been considering, this is the block diagram of a first order system. Now, this is G of S and this is unity feedback system, where H of S is equal to 1. Is that okay? Right? Now, if I try to evaluate the overall C of x by R of x transfer function, G divided by 1 plus G into H. Is that okay? Right? Now, what is G? G is 1 by Ts divided by 1 plus 1 by Ts into 1. After simplification by taking LCM, what do we have? C of x by R of x is equal to 1 divided by Ts plus 1. right? Now this is the closed loop transfer function of the first order system what we have been considered. Now normally we had two things, zeros and poles. In future you need to memorize this very clearly. We'll have two things, zeros and poles. Across any given control system, we'll come across two kinds of rules, zeros and poles. Always zeros it lies in numerator. Where do we come across zero? Zeros it always lies in the numerator part, wherein poles it in the transfer function, there are no zeros. As one is constant, thereby it has no roots. Now, but in the denominator, we have how do we evaluate that pole? It is quite simple. You can have a look. TS plus 1. This system has one pole located at TS plus 1 is equal to 0. Or I may transfer this to RHS. What is this? It becomes TS is equal to minus 1. After simplification, TS is equal to minus 1. Or what is S? S is equal to minus 1 by T. Right? That means we have one pole lying at minus 1 by T. And with this, the T is referred to as with this, the T is referred to as time constant. Now, coming to the detailed analysis, you can have a look. Now, we are interested in finding the first time response analysis of a unit step input. ಇಲ್ಲಿ ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಇನ್ಪುಟ್ ಆಗಿರೋದ್ರಿಂದ ನೋಡಿ ದಿಸ್ ಇಸ್ ಅವರ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್. ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ಆರ್ ಆಫ್ ಎಸ್ ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ ನಾನು ಈ ಕಡೆ. ಅವಾಗ ಏನಾಗ್ತದೆ ಸಿ ಆಫ್ ಎಸ್. ವಿ ಆರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಇನ್ ಫೈಂಡಿಂಗ್ ಸಿ ಆಫ್ ಎಸ್. ಸಿ ಆಫ್ ಎಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಔಟ್ಪುಟ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್. ಇದನ್ನ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ವೈ ಬಿಕಾಸ್ ದ ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ವಿ ಫಾಲೋ ಇಟ್ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ದಟ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಸಿಸ್ಟಮ್. Now what is C of S? 1 by Ts plus 1 into R of S. Now what is R of S? R of S is 1 by S. Now how do I get this 1 by S? This is the Laplace transformation of like unit step input, right? Next, how about C of S? C of S is 1 by Ts plus 1. This is one separate expression into 1 by S. ಇಲ್ಲಿ ಆಕ್ಚುಲಿ ಪ್ರಾಡಕ್ಟ್ ಇದೆ. ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ನಾನು ಸಮ್ಮ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ಸಮ್ಮ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಐ ನೀಡ್ ಟು ಗೋ ಫಾರ್ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ ಅಪ್ರೋಚ್. Now, if I go for partial fraction approach, how do I write this? For partial fraction approach, you need to satisfy one condition. What is that condition? The order of the numerator should be less than the order of the denominator. Now, what is the order of the numerator? Actually, this is zeroth order. What is the order of the denominator? Second order. Illi zero ide, illi second order ide. Condition satisfy ಆಯ್ತು. Partial fraction approach na apply ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನ್ condition satisfy ಆಗಬೇಕು? The order of the numerator should be less than the order of the denominator. That has been satisfied. What is the order of the numerator? It is 0. What is the order of the denominator? It is 2. ಅವಾಗ ಇದನ್ನ ಹೇಗೆ ಬರೀಬಹುದು? A0 by S plus A1 divided by TS plus 1. Why? Because this is separate term and this is separate term. Partial fraction approach is always meant in converting product of terms into sum of terms. Is it okay? Then how do I get the value of A0? It is quite simple. A0 ವ್ಯಾಲ್ಯೂ ನಾನು ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಈ ಎಸ್ ಅನ್ನ ನಾನು ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. ಈ ಎಸ್ ಅನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ is it okay? Now I need to avoid this here. Now how do I avoid this yes? ಇಲ್ಲಿ ನಾರ್ಮಲ್ ಮೆಥಡ್ ಫಾಲೋ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಇದನ್ನ ಕ್ಲಿಯರ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ನನಗೆ I need to know the value of A0 and even I need to know the value of A1. Now to know the value of A0, I need to avoid this S. ನೋಡಿ ಟೋಟಲ್ ಸಿ ಎಫ್ ಎಸ್ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. ಅದೇ ರೀತಿ ನನಗೆ ಟಿ ಎಸ್ ಪ್ಲಸ್ 1 ಇದು ಕಾನ್ಸ್ಟೆಂಟ್ ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಟಿ ಎಸ್ plus one simple model. Yes, avoid I shall multiply by C plus one.